Hi, my name is Lucanio Mangona. With Maths Tutoring Services, which specializes in maths and science tutoring. We do our tutoring for from grade 6 up to grade 12, and we help learners with mathematics, the sciences, and the language of learning. So if you're really interested for us to actually help you or your child with any of these subjects, you see our number just either at the start of this video or at the end of this video. Please get in contact with us so that we can be able to help your child. So if you're watching this video, you most probably are a concerned parent, or you are simply a grade 11 or grade 12 learner who's just worried about what it is that's going to happen with your education and all your academic work. So one of the things that I am doing, what we are actually doing now, is to try and help you. So as much as you are actually sitting there at home and then you're trying to do the learning, so we put together these videos so that we can help you with, so that you can supplement whatever work that you are actually currently doing. So in this video insert today, we're going to be dealing with mathematics, and in mathematics we're going to be still specifically with grade 12 trigonometry, which is all the work that you do for paper 2. So that's what we're going to be dealing with here. So one of the things, the purposes of this video, is that I'm going to take you through all your grade 10 and grade 11 basics of trigonometry, which is still required for, or rather something that will be examinable for you for grade 12. So for this video, I'll be focusing on those things. We're gonna be starting by looking at the cast diagram. We're gonna also be looking at the meaning of the trig ratios. We're gonna be looking at some special angles, and then right at the end of the insert, we'll be looking at some of the different examples, and how all of the information we're going to be learning today, how all of that we applied on those problems that we get, that the examiners will be asking us on. So in the next insert, we're going to be looking into that. So yeah. Cool. Okay. So like I mentioned in the introduction, so I'm going to start taking you back to grade 10 when you were a little munchkin, and then we were introducing you to trigonometry. And if I can take you again 2 years back, again in grade 8, we've introduced you a type of triangles. There were actually 4 triangles that we introduced you on. It was the Equilateral Triangle, which has all the sides equal, and another one is the famous one, which is the Isosceles Triangle, which has the two sides that are equal with the corresponding angles that are opposite angles that are equal to each other. And the very third one is the Scalene Triangle, which is has all the sides and all the angles that are not equal to each other. But more interesting for the purposes of today is the fourth one, which is what we are seeing here. If you look at this, is what we call it a right angle triangle. And this right angle triangle, it's very important for us to understand, because one of the angles there is a 90-degree angles, and hence the name right angled, which is right angle meaning 90 degrees. And but also it has all the other three sides. But now I just want us to look at triangle ABC. And if we're looking at triangle ABC, and then we slightly focus on angle A, right? So, for instance, I just want to explain some of all of these sides here. We said the side that is opposite to which is the longest side, in this case is AC or small letter b, which is, now this is the longest side, which is that side that is very directly opposite the 90 degrees, is we call it the hypotenuse. And that's the new term, but you've been hearing it for 2 years already now, so you might be familiar to it. But if we're looking again at angle A, we're looking at that angle, sorry, at that side here that is directly opposite that angle A. We call this side as an opposite, and to angle A as well. And we look at the side that is adjacent, which is adjacent is nothing much more fancier than just it's a side that is next to this angle A here, which is this side here, which is so. But now if we're looking at this angle A here, we can make this explanation if we're talking about the sine of angle A, we're talking about opposite over hypotenuse, which is in this case is A, which is the opposite side, over B, which is the hypotenuse side here, if you still remember. And then again, cos of A will be C over B, which is the adjacent side, over hypotenuse, and the tan, which is opposite over adjacent, which is basically the opposite side over the adjacent side. So, and then the same thing you could do here for angle C, which is probably, I won't do it, but if we're looking at sine of angle C is opposite over hypotenuse, which is C over, so you look at opposite side to angle C, it will be that opposite, which is, then we said small side C over B, again the hypotenuse. And the same thing happened to cos, which is adjacent, so adjacent to this will be that side over B. And then now here the tan of C, sorry, we've made a mistake here. It's the tangent of C is that opposite over adjacent again. So that opposite over adjacent and that opposite. So we're looking at angle C here over adjacent being that angle A, right? So one thing that I want us to look at now, so if you again jog your memory back into grade 10 again, we've introduced an acronym for you which said so ka to 1. And then basically what this thing is, it basically just explained all of these things. Sine is opposite over hypotenuse, and hence that's so. And cos is adjacent over hypotenuse, and then tan is opposite over adjacent. So this is one of the things that you need to actually do in order to make sure, because most of the time I talk about this and people think that I'm making a joke about this. What you need to do if you're learning maths is almost like you need to have your mathematical toolkit, which is something here that you need to actually put it into your toolkit. So for your trig part of it, so if we're talking about so we're looking at those things. But now the next level is that we need to look at how all of these trig ratios, which is sine, cos, and tangent, they apply themselves in terms of when we put them into the Cartesian plane. Okay, so one thing that we wanted to look at in this section here is we want to look at the Cartesian plane. So I'm just gonna start it from scratch just to draw it nicely, so that I know this can be painfully boring, and which is the case that you actually see also in class, that this is not actually fully explained to us in grade 10. So I just want to go through that whole painful process so that you can actually fully understand. And again, here, I just want you to make sure that even if you were, in some other parts of this video, you were just sort of snoozing your way through it. But I just want you to listen very, very, very clear, because one thing that we are finding from my experience is that people were not listening at the time when this was introduced to them in grade 10. So please, 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 my experience is that many people do forget all the basics, and these basics now are coming up to haunt you in your grade 12, because all these foundations that you were taught then, it's simply that people may have forgotten them. So I just want us to start by looking at this x's here, and then if we start with the x-axis here, and then these are the y-axis, right? And then in this Cartesian plane here, I just want to explain a little bit here, is that this is the positive part of the x-axis, and this is the positive part of the y-axis, and this is the negative part of the x-axis and the negative part of the y-axis. So suppose here we take an acute angle, let's call it, for the purposes of this, is, and when I talk about the acute angle, I'm not being fancy there. We're just talking about an angle which is less than 90 degrees, which is an angle that is between 0 and 90 degrees. So, and then I want us to then reconstruct this right angle triangle, where we produced a y here, and then we produce an x here. So now here, if we're looking at this angle theta here, so if you look from the previous section where we explained all our all our trig ratios, is that we said the side here that is actually opposite the 90 degrees, we said that that is the longest side of that right angle triangle, and then we call it hypotenuse, right? And if we focus on angle theta here, and then this side here, if we explain here, this is the opposite side of angle theta, as you can see. And again here, opposites, it's just the side here which is directly opposite that. And then this side here is that we're looking at the side which is next to, and then we call this side here adjacent, right? So this angle here on adjacent is then okay, so this then is what we call it the adjacent side. But one of the things that I just want to again explain here with this Cartesian plane is that what you would notice, especially for those of you that do physical science as well, you'd note that in mathematics and trigonometry, to be specific, is that we start here, right? This is 0 angle, and then if we go in this direction, we go in the positive direction. So if we move from that angle here is 90 degrees, and then that is 180 degrees, and then here is 270 degrees, and then we return back here to 360 degrees, right? But now that's, so what we note here is that if we go in this anti-clockwise direction, which is that if we're going in this direction, we are moving in the positive direction. But now, so it's almost like what we do with the number line is that if you go to the right of the of 0, you would see that those are the positive numbers. But now if you go in the opposite direction, which is 0, which is all the negative numbers, will be on your left hand side of your number line. So the same thing here happens, is that if we move in the clockwise direction, which means if we follow the clock, now we move into the, I just want to, for the purposes of making things clear, I'm going to write this with a pencil. So these are the negative. So if this is 0 degrees, this becomes minus 90 degrees, and this becomes minus 180 degrees, and this becomes minus 270 degrees, and then this becomes minus 360. Right? So you would see when we start talking about some of these trig functions, how all of that is illustrated when we talk about the trigonometric function, how all of this moving 0 degrees, 30 degrees, 90 degrees, and then and so on and so on. But you would also see that now we're going to start having minus 30 degrees, minus 60 degrees, and all of that. So, but just explaining it from the perspective of the Cartesian plane, this is how we, for instance, if somebody is asking you, is that where will I locate, in which quadrant is angle minus x or angle minus theta? So you see that if I'm moving in this direction, so that acute angle here, it will be in this quadrant here. So that's the fourth quadrant. But another thing I want to explain here is that this is the first quadrant, this is the second quadrant, and this is the third quadrant, and this is the fourth quadrant. So if we now we just want to look here on all these three ratios. So for instance, we start by sine of theta, we look at cos of theta, and we look at tan of theta. And again here, folks, I just want to explain to you is that this is when you need to actually, because this is all the basics that we learned when we were all young and munchkins in grade 10, when they started introducing this whole concept of trigonometry, because everything, it almost like hinges on you clearly understanding all of this. So again, I just want you to make sure that you fully concentrate. So if we go back to the previous section where we spoke about the SOHCAHTOA. So if we're looking at sine is opposite over hypotenuse. If we look here as opposite over hypotenuse, and opposite being our y over r here, which is the hypotenuse here. And again here, I just want to explain to you, because we keep saying that our r is always a positive y. If we look at the Pythagoras theory, it tells us that the square of the longest side is equal to the sum of the two squares of the other side of the right angle triangle. So whichever way here, our r value will always be a positive. Be this is negative or that is negative for that matter. So it really doesn't matter. So now And again here, I just want to explain. So if we look at y over r, so if you're looking at y over r, so you see on the first quadrant, y is positive over r is positive, right? And now if we're looking at that, at this one, so positive over positive, it will give us positive. Let's now look at cos, which is adjacent over hypotenuse, which is x over r. Again here it is positive over positive, which does give us a positive as well. So the tan of theta is equal to opposite over adjacent, right? And then that opposite over adjacent again here is opposite being y over adjacent, which is x. So again here positive over positive, which is equal to positive. So now what we conclude from the first is that all of these ratios here are positive. And now I just want to look at all the other ones quickly, just to make sure that we, like I said before, we're just going to go through this painful and boring process so that you can understand everything about how these ratios sit on our Cartesian plane. So again, here we have a y, and then we have an x, and that is an r. So I do not need to explain again here. Obviously, this becomes our hypotenuse. So if we're looking at the angle here, the angle being theta, so this being an opposite side, right? And this being an adjacent side, right? So again, here we can do quickly. Sine of theta is opposite over hypotenuse. And then that opposite is just y over x, or rather it's y over r, I beg your pardon. And your cos theta here is given by adjacent over r, over hypotenuse, which is x over r here. And then the tan, sorry, things are get bit messy now because I'm trying to squeeze in everything to try and make my point through here. So this is now again is 10 is opposite over adjacent. So now here, this, if I may just squeeze in here, it is y over x. Now we need to do the same thing that we did here to see how these things sit here. So y is positive, if you may, here, and then the r, we said because of that it will always be positive. Again, sorry, I just needed to write. So this is positive. So let's look at x here. So x is negative here, right, over r, which is always positive. So that gives us a negative, right? And then again here, if we look at the tan, and y is positive over x, which is negative, so it gives us a negative. So here what we are seeing is that it is only sine that is positive here, right? So we can do the same thing here for, if we reconstruct that, so this becomes r, this becomes y, and this becomes x here. So well, we've already written the x here. So let's do quickly the same thing here. So sine of angle theta, sorry, I should have written there that angle theta. So sine of theta, I'm just gonna try and bypass all. Sine being that opposite side, which is just y over r. Right, so if we're looking at y here, these are negative parts of this, so that becomes negative over positive, right, which is negative. So, and then if we do cos theta is adjacent, which is this part here, adjacent over r, so it is x over r. Again here, if we look at this, x is negative over a positive, which gives us a negative, right? And then if we do tan theta here, let's just try and do it somewhere here, which is now opposite, which is y over x. So if we look at that y over x, it's negative over a negative, which gives us a positive. So now what we are seeing is that in this quadrant here, we see 10 is actually the one that is positive. And here you may be able to predict here already what will be the situation is, but let's just try and redo it again in that painful manner. But it, as much as it is painful, but it is actually helps us, because as soon as you can see the Cartesian plane in this way, then you can be able to navigate your way through all the other section. Again, let's start here. So we have an angle, we call that angle theta. So if we look at sine of theta here, so let me just so we have r here, we have y here, and obviously we have x. So sine of theta is given by, so sine is opposite, which is y over r. So y is negative there, so if we look at that, so over a positive, which is r, remember from that, so then that gives us a negative. So if we have a cos of theta here, so that becomes x over r, right? So again, adjacent over hypotenuse, which gives us a positive over a positive, right? So that gives us a positive. And then the tan of theta is given by, again here, tan is opposite, which is y over x. So this y over x, it will be y, it will be negative for y over the x, which is x is positive, sorry, so now that is negative. So as you may have correctly correctly predicted here, that on the fourth quadrant you have the cos that is now one thing that we now have created. We have seen that all of them are positive here, and only the sine that is positive here, and the tan that is positive here, and the cos. Again here for your toolkit, you have created what we call it the cast diagram. The cast diagram. So for those of you who live around Cape Town, the teachers may have explained it, that cast diagram, as all stations, that's for S, all stations to Cape Town. But basically what it is what we call it. So if you look at this is your fourth quadrant. Only cos is positive in the fourth quadrant, and all they are positive on the first quadrant, and then on the second quadrant at sine that is positive, and then on the third quadrant is that. So basically again here, these are, like I am saying, and to you guys, and I keep reiterating, and that's the same thing that I do if I happen to walk into a grade 8, sorry, rather a grade 10 class, and introduce this subject. This is one of the things that I need you to actually understand, because as soon as you can understand this whole thing, how these things manifest themselves out of that cast diagram, then it makes up to 60% of your life through your trigonometry much easier. It means that you will also understand when we get a bit more complicated with the graphs. It means that you will be able to understand when we talk, for instance, about our next session here, which is when we talk about the reduction formulas, and then the ratios and their core ratios.